So we're continuing on with section 12-2, and we're going to go over 8 limit laws. So the first limit law is the limit as x approaches a of, and then we're going to go ahead and add them together. So it'll be f of x plus g of x can actually be simplified. So the sum, or the limit of a sum, is the sum of the limits separately. So it's the same as the limit as x approaches a of f of x plus the limit as x approaches a of g of x. So the limit of a sum is the same as the sum of the limits separately. That's the first law. Second law. The limit as x approaches a, so of f of x minus g of x, is the same as above. So this one is a difference. So the limit of a difference is the difference of the two separate limits. So it's the same as the limit as x approaches a of f of x minus the limit as x approaches a of g of x. So you can subtract the two limits separately if it's the limit of each of these together. Alright, number 3. Okay, so we have a limit as x approaches a. This time we're going to multiply a constant times a function, so c times f of x. So a constant times a function, the limit is the constant times the limit of the function. So we can pull out that number, the constant, and then we can just multiply it by the limit as x approaches a of the function f of x. So you can just take it out. Alright, number 4. The limit of a product. So we're going to do product. So the limit as x approaches a of f of x times g of x. You can probably guess what it's going to be. So you can break them apart into two separate things. You can take the limit as x approaches a of f of x times the limit as x approaches a of g of x. So you can basically take the limit of each of the functions separately and then multiply them together. So the limit of the product is the product of the limits. Alright, I'm going to erase this and go on to the last 4. So number 5. The limit of a quotient. So since we did product, we're going to do quotient. So the limit as x approaches a of f of x over g of x is equal to the quotients of the limits. So we can take the limits of each separately. So I guess I should have put parentheses around this. So it equals the limit as x approaches a of f of x divided by the limit as x approaches a of g of x, the denominator. There is one little condition. The denominator can't be 0, so that limit can't be 0. So I'm going to say can't equal 0, that limit. Otherwise, it's undefined. Alright, so for number 6, I'll change it back to black. It's the limit of a power, is the power of the limit. So I have a limit as x approaches a of f of x raised to the nth power. That is equal to the limit as x approaches a of f of x. So you can find the limit, and then what you can do after you find the limit is raise that number to that power. So that's the same. So the limit of a power is the power of the limit. Alright, number 7. The limit of a root is the root of the limit. So this is what this looks like. The limit as x approaches a of the nth root of f of x is the same thing as taking the limit of f of x. So the limit as x approaches a of f of x, and then taking the nth root of that. So that could be square root, cube root, or whatever. So you find the limit, then take the root. Alright, then the last one, I think I can fit it down here. The limit of a constant is always the constant. So if I just have like a number 5 or 7 or 12 or -5, the limit as x approaches a of just a number is always equal to that number. So in this example, we're going to use the limit laws in this graph to help us evaluate each of these. So the first one is the limit as x approaches -2 of twice f of x minus g of x. So we're going to go ahead and simplify these a little bit. So we're going to first do twice f of x right here. This is the same thing as, I believe, number 3, limit law number 3. A constant times, the limit of a constant times a function is the constant times the limit of the function. So this is the same thing as 2 times the limit as x approaches -2 of f of x. And then minus, and then we're going to use the second one, the difference, the limit as x approaches -2 of g of x. And so we're going to go ahead and use the graph to find that. So f of x is the one in red here. So as x approaches -2, so here's -2 right here. As x approaches -2 from each direction, the y value is 1. So I'm going to get twice 1 minus, and then as x approaches -2 of g of x, that's this second one, from the left and from the right, it looks like it's going to be -1. So I get minus a -1. And when I go ahead and simplify that, I end up getting the limit as 3. Alright, the second example that I have is the limit as x approaches 1 of f of x squared. Okay, so what we can do is we can go ahead and find the limit as x approaches, right, I guess we can find the limit as x approaches 1. So let me erase on the drawing, so these will be gone. And we want to approach 1 on f of x, and then we're going to square that answer. So I will come in towards 1. So here's f of x, the one in red. So when I come towards the right from the left, it's it looks like it's 2, and then I come in from the right, it's 2 as I approach 1. So the limit is 2, and then I just get 2 squared, which is 4. So my third example, I have a limit as x approaches 3 of f of x over g of x. So we can calculate the limits separately. This is the same thing as the limit as x approaches 3 of f of x divided by the limit as x approaches 3 of g of x. And this will work as long as g of x doesn't equal 0. So using the graph, here's 3. So here's 3. Now remember, f of x is the one in red, so as I approach 3 from the left, it looks like it's about a half. And when I approach, when I approach 3, we're going to 3, it looks like it's 0 from either direction. So I end up getting 0. And then when I approach 3 on g of x is approaching 3 in this direction. So here's 3. It looks like it's going to approach 1 from this direction and this direction. So it looks like the limit is 1. And that would just be 0. It's not undefined because the denominator isn't equal to 0. And in my last example, I have the limit as x approaches 1 of f of x times g of x. So we can go ahead and calculate the limits separately and then just multiply them together. Because if you remember the limit law, this is the same as the limit as x approaches 1 of f of x times the limit as x approaches 1 of g of x. And we can just multiply the two values together. So here's 1 again. F of x is the one in red, so as I approach 1 from the negatives, it looks like it's 2, and from the positive, it's 2. So I get 2 times, and then as x approaches 1 from the negatives on g, it looks like it goes to -2, but when I approach 1 from the positives, it looks like it goes to 1. And because these don't connect, or they go to two different values, this does not exist. If they went to the same number, it would. So basically, the limit isn't possible. It does not exist. So you can't multiply one that does and one that doesn't. So here's the last example, and I'm actually going to give you problems to do and bring these to class, and we'll go over them tomorrow in class. I want to see if you guys can do these. So the goal is to evaluate by direct substitution. Alright, so this is me checking your understanding so far. So I'm going to be asking for these tomorrow, and again, I will go over them. So the first one I want you to find is the limit as x approaches 2 of x squared plus 6x over x to the 4th plus 3. That's x to the 4th plus 3. Alright, and I want these all done algebraically, if possible. Alright, second one. I want you to find the limit as x approaches 4 of x minus 4 over x squared minus 16. Third one, I want you to find the limit as x approaches 10 of just 3. It's one of our limit laws today. So find the first two algebraically, and then number 3, use one of our limit laws from today. So I will see you tomorrow.